So starting with 14.5, they talk about elements versus compounds. And we might have brought this up already, I'm not positive. But I figure since the book mentions it here, it's a good time to reiterate it, even if you've heard it before. So elements, those things you see on the periodic table here, one square for each of them, are atoms of a single kind. All right, any element is made of one kind of atom. They may differ in their number of neutrons, but they have the same number of protons. So, and these atoms of groups of these atoms, of these single atoms, make up the elements that we know. When you're writing elements, formulas for the elements, as you remember, we use an uppercase letter or an uppercase, then a lowercase letter. And you can have just single atoms as symbols for elements. So for instance, Ne is neon, B is boron, and Si is silicon. We have two atom elements, otherwise known as diatomic elements, diatomic meaning two atoms. And they are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And whenever you show these elements by themselves in a formula or in a chemical equation, you always have to put a subscript 2. Now, if this is, say, if chlorine is bonded to something else, it doesn't need the 2, but when it's by itself, it does. How do you locate these? Well, there are 7 of them, 1, 2, 3, 4, 5, 6, 7, and 6 of them actually make up the shape of a 7 on the periodic table. I had no idea of this, but my son taught it to me when he was in 5th grade, because his 5th grade teacher told him that. So if we look at a periodic table here, hydrogen's over here, and it's really not part of the 7. But if you look starting from nitrogen here and going across to fluorine and down to iodine, and yes, I am writing in a book, something I rarely ever do, you can kind of see the shape of a very square 7 for the other 6. 1, 2, 3, 4, 5, 6. So that's how you remember what the diatomic elements are. And then you just have to remember hydrogen, which is off on the other side. There's a few elements which comprise more than 2 atoms. Phosphorus exists in clumps of 4, P4. Sulfur exists in clumps of 8. We write it as S8, but that's only when they're by themselves. Compounds are 2 or more atoms, of different elements that are bonded together. So for instance, it isn't just 2 or more atoms, they have to be of different elements. Here we had 2 or more atoms bonded together. Okay, so for instance, water has a formula H2O. This 2, this subscript 2, is telling us that there are 2 hydrogens. There's an understood subscript of 1 by the oxygen. We don't write it down, but if you see the symbol and no subscript, it means there's 1 of them. So H2O means 2 hydrogens and 1 oxygen. If we have carbon dioxide, the formula for carbon dioxide is CO2. That means you have 2 oxygens because there is a subscript 2 by the oxygens and a single carbon. A subscript only refers to the element directly before it. So this 2 has no bearing at all on the C. So the number of each element are given by a subscript. Now if we're talking about compounds, the book gives you the formation of sodium chloride as an example. Sodium, which is a solid, reacts with chlorine, which is a gas, and I'm showing chlorine by itself, so I'm writing Cl2, to produce sodium chloride, which is a solid. This is not a balanced equation. We'll get around to balancing equations later, but the numbers of chlorine on both sides are not the same in this case. And what your book talks about at the end is that the physical and chemical properties of the compounds, such as sodium chloride, are very different from that of the original elements, sodium and chlorine. Sodium is a very reactive metal. If you put it in water, it will fizz, hiss, not quite explode, but be very, very vigorous and kind of fun to watch. Chlorine is a very reactive nonmetal. If you were to take a deep breath of just elemental chlorine gas, it would burn your lungs. Sodium chloride doesn't really have much wrong with it. It's plain old table salt. If you eat too much of it, it could raise your blood pressure, could make you really thirsty for a day or two, but it's not harmful. So you take these two things that are rather harmful and reactive and put them together, and they make something as innocuous as table salt. So there we've got elements versus compounds.